Here we go. Bit. What's up, Jimmy? Take it the ping worked. Hello, everybody. We have 4 folks already. I'll get started at the 2-minute mark. So in about a minute and 15 seconds. Hello, Level Up. All right. 6 folks already. All right, welcome everybody. I'll get started in just a moment. I will be reading to y'all a report I have written for my honors class. So it's going to be a good time. So 3 pages long. All right, we'll get started in about 10 seconds. All right. Well, we might as well get started. It seems we have leveled out at about a good 5 people, and I'm happy with that number. All right, so it takes a village of zooids. That's the title of this paper I've written. So here we go. Across the globe, various strange creatures lurk within the waters of the various oceans, each with its own unique set of traits. For example, spindly tentacles, bulbous core, translucent body, and fluid like movements. With these key traits, the first thing that comes to mind might be jellyfish. However, there's another aquatic beast with the same traits, plus more. The siphonophore. I've talked about these guys a lot, but makes for a good topic. A massive colony of specialized microorganisms working together in tandem with one another, each serving a unique purpose to support the colony and enable its capabilities. What is the purpose of these specialized organs? Siphonophores are a unique series of organisms that instead of forming one organism, they make up a colony of organisms that take the shape of something similar to a jellyfish. Unlike jellyfish, however, siphonophores are far more complex, relying on each tiny component to create and maintain different functions on the colony. Siphonophores are made of thousands of microorganisms called zooids, which work together in a large colony to grow and maintain the structure of the siphonophore colony. According to Cat Monroe, there are over 170 species of known siphonophore colonies, each one living most of their lives, which happen to be very active in the deep sea. A key trait of siphonophores is, as previously stated, their mobility. Unlike jellyfish, siphonophores have coordinated movement, which is thanks to their specialized organs that are maintained by the zooids in the colony. According to Kyra Schleining, within siphonophores, each body is highly specialized to serve a function such as swimming, eating, digesting, reproducing, and defending the colony. Due to the specialized zooids that evolved to serve unique purposes, the siphonophores are able to work as a village, each collection of zooids putting energy to their quote unquote job to create the organ. The unique organ structure allows for more complex movement as the zooids that specialize in maintaining the locomotion also operate locomotion, as is the same for the other organs created by the zooids. However, one might ask, how are the zooids capable of being their own independent organism while still contributing to a colony hive mind? The answer is, despite the siphonophore being a colony rather than a single organism, there is still a nervous organ that helps organize the zooids in early development, as well as sometimes in adulthood. According to Aquarium of the Pacific, the The egg becomes a protozooid that buds to form the different structures with their different functions. Polyps of the same siphonophores become reproductive cells that contain sperm or eggs, meaning that in early development, the center of the siphonophore almost branches out like a tree, and the quote unquote branches that follow are the beginnings of the specialized organs that the zooids will create. As the siphonophore develops, the number of zooids increases as the colony branches further outwards to increase size and make room for new organs to compensate for the size increase and maturity for reproduction. Various organs are created to aid the rest of the colony. As zooids that serve one function, such as feeding, for example, are incapable of swimming or defending the colony. As is the same for zooids that can swim, they are only capable of swimming and not feeding or anything else. The colony is completely codependent, resulting in astounding synergy. According to siphonophores.com, there is a high degree of specialization between zooids. Zooids specialized for one function usually have well developed features to serve that function, but lack the structures associated with other functions, which supports the claim that the colony relies on its specialized organs as the colony cannot function without them. The colony builds its body on the stem that is developed first after fertilization. The stem houses a pneumatophore at one end, which is a gas-filled float responsible for the balance and buoyancy of the colony. Behind the pneumatophores is the key locomotion, the nectophores, which are advanced medusae zooids that are responsible for moving the colony from place to place. Below the nectophores lie the cyphosome, which are responsible for feeding the colony through long tentacles that bring food to feed and support the colony. The cyphosome also houses the reproductive organs, which vary from species to species. Some siphonophores house both reproductive organs, while others will only house one or the other. Also, according to siphonophores.com, the eggs and sperm of siphonophores all mature in specialized reproductive medusae. These medusae can be retained within the colony for their whole life. Sorry about that. Whole life, freed into the water, or grown on specialized polyps or groups of polyps. Due to the medusae being able to swim freely upon deployment for reproductive purposes, scientists consider zooids individuals, despite them being reliant on other specialized zooids in the colony. The argument states that as long as the means of reproduction has free movement and holds the same composition and title of other zooids, the fauna-phore colonies are considered groups of individuals working together rather than a single colony. There we go. My screen, it isn't backwards. Huh. Yeah, no, you guys say it's backwards, but for me on the screen, it's coming out as clear for me. Well, yes, I know it's inverted, but when it's on the camera, like showing what you're recording, every other time it's been just fine. But I don't really think it's an issue. But there, that better. There we go. That is my report. All I need to do is do the works cited. I have the links down. I just need to, properly cite it, APA and all that. Thank you. I still need to edit it a bit. It's due next week, but I got kind of carried away during one of my classes and I just kind of knocked it all out while I was sitting there. It was a good bit of fun. Swag. Are there any questions. YouTube set channels my works cited. Maybe I'll just try. Don't worry, Jimmy. I often do that, but this is Safan Force. Those always come first. So, do we have any questions or anything else, or is it wrap up time? Excuse me. Just trust me. Sources are from me. Oh, but they are not jellies at all. They are siphonophores, which are very cool. Largest siphonophore grows to be the 30% larger than the blue whale. Well, 30% longer. They're only about as thick as a broomstick, but like a giant fishing net. Cool though. Ooh, excuse me. All right. Well, since we have no questions, I guess we'll wrap up tonight's stream. I'll go put some medicine on my eczema, and then I will probably go to bed. So, good night, everybody. Hope everybody enjoyed that little special of reading the detailed lives of the siphonophores. So, a fish tier list? Sure, why not? I'll have to print out lots of little things though, because I can't screen share because my computer's old and can't run OBS. So, good night, everybody. Like always, stay safe, ask questions, feel free to leave suggestions anytime, and goodbye, fishy friends.